Good afternoon, everyone. This is Hakam Asawi. I'm technical support engineer at Elnady Engineering and Agencies. We are the sole distributor of COMSOL Multiphysics in the Middle East and Arab countries. Today, we're going to talk about COMSOL Multiphysics. It's a brief introduction about COMSOL Multiphysics of two parts. This is part one. Part two would be next Monday. On Wednesday, there is an Arabic version of this webinar. And on the Wednesday after is an Arabic version of part two at the same time. If you have any questions, please submit your questions on these two email addresses at the end of the webinar, or anytime. If these are the support email addresses for our company. If you have any questions about the software, we need a quotation, or have any inquiries about which modules or which parts of the software you would need or use, please contact us on these emails or phone number. So let's start. Today's agenda, we're going to talk about what is COMSOL Multiphysics, what can I use exactly COMSOL Multiphysics for, or what are the fields of application for COMSOL Multiphysics and its modules. And we're going to have a brief introduction about the interface, how it looks like, what kind of buttons we can find, what kinds of stuff we can find in the COMSOL Multiphysics. And part two, we're going to go deeper into the software and actually building a simple model using some of the modules we have. As for COMSOL itself, COMSOL is a Swedish company. Actually, it's currently an international company based in Sweden. We have more than 20 offices worldwide working on developing the software and its modules, and more than 400 employees working on this tedious task. You can find many people working with COMSOL Multiphysics either in academia or in research or development in some other corporations. Many of the big names in the industry actually use COMSOL, like Boeing, NASA, Saudi Aramco, BP, and much more. You can find the big list of people who actually work with COMSOL on the website, comsol.com. Why we use simulation softwares in general, not just COMSOL, but in general. We use them to understand how our designs or how our systems we're designing or working on, how do they work, explore them, switch between different designs and different parameters, it's more flexible than actually prototyping in real life. We can also use certain simulation softwares to verify parameters we're working with, limitations of the system, and actually running the system safely, or working with the design safely without having the dangerous situation of having it working on as a prototype and endangering people's life or nature. We have also the optimization part. Using COMSOL, you can optimize your designs, you can optimize your systems, you can see how it works and how can changing certain parameters or solving the model backwards, if I'm like having a certain output, changing it, and then seeing how which parameters you should change to satisfy this equation or this model. Using COMSOL Multiphysics, the multiphysics part indicates they have multiple equations or multiple physics being solved. What we call here physics is just an equation. For example, if we have heat transfer, we have a heat transfer physics. If we have fluid flow or fluid dynamics, we have fluid CFD or fluid dynamics physics, and so on. Working with COMSOL, you can use your model as a single physics, building just for a single equation being solved, or just single physics, or have it as a multi-physics, and multiple equations being solved together at the same time or concurrently. There is no limitations on how many multi-physics or how many equations you have in your model. The only limitation will be your system and how much it can handle based on the specification of your hardware. We have also a built-in material library, which comes with each and every module, its own like mostly used materials. You can also add an additional material library as an extension or an add-on module, or you can input whatever material you would like to work with as a blank material, rename it, and enter the specification for said material, and save it for later use or send it to your colleagues to work with. So as you can see, the flexibility is endless here. Also, you can work with the predefined multiphysics and predefined couplings and equations that are built into the software and you purchase it. or you can define your own multiphysics or equations as partial differential equations or linear differential equations and or just algebraic functions. Whatever you would like to define in COMSOL, it can be solved. You don't have the black model or the black box model system where you don't know what's behind this door and you have to work with it as is. You can just use the equations built in, modify them, or just enter your own equation or whatever you want. You can use COMSOL multiphysics as multiple physics as an uncoupled system, or one-way coupled system, or a strongly coupled system. Okay, uncoupled system, you can have a single model which has multiple interfaces or multiple uh, equations being solved for, each being solved separately without the interaction with one another. This is an uncoupled system. You have also one-way coupled, where one equation or one physics is being solved, and whatever output from it is an input for the next one, and so on. Or a strongly coupled system when you have all the physics affecting each other and being solved together. An example for this is this small micro resistor, where you have a micro resistor beam between two supports. An electrical current passes through the system, which induces a Joule heating effect and starts heating up. Affecting it, the material starts buckling and extending and start buckling because it's stuck between two supports. When we add the fully coupled system, because this is a one-way coupled system, when we add a fully coupled system, we get this effect. This thermal expansion affects the dimensions of this beam. For example, the cross-section changes, and thus how electricity affects it. And also the temperature distribution along the whole material or the whole beam affects the material properties and changes them based on the electrical current also affects is being changed. So this is a fully coupled system. The modules we have for COMSOL, currently we have all these modules. We have electromagnetic modules where we have AC, DC, radio frequency, wave optics, ray optics, plasma, and semiconductor. This is the branch where you have all the modules, and each and every module is separate. So whatever you want to purchase is just a single module, not all the modules. You can also select whatever other module. For example, for fluid flow, you have computational fluid dynamics and the mixer module, microfluidics, metal processing, molecular flow, subsurface flow, and porous media flow. The porous media flow is one of the new additions to the family. It has been added last November, I think. Also, we have one of the new additions, which was added last year, is like the composite materials module. We have also structural mechanics, fatigue, multi-body dynamics, micro electromechanical systems, and acoustics. As for the chemical reaction engineering, we have chemical reaction engineering, batteries and fuel cells, electrodeposition, corrosion, and electrochemistry. There is also a multi-purpose module. These multi-purpose modules are an additional tools you can use in COMSOL, like optimization module, particle tracing, and the extended material library, which adds more than 2,500 materials to the library, including alloys, composite materials, elements, and so on. The last branch we have is the interfacing products. These products allow you to connect COMSOL to other programs like MATLAB, Excel, SolidWorks, and so on. What we have is live link. Live linking COMSOL to other softwares allows you to have both running side by side, and whatever you have in this software, for example, MATLAB or Excel or SolidWorks, can be synchronized with the COMSOL Multiphysics. So if I'm building a geometrical structure like a CAD, using a CAD software like AutoCAD or Revit or SolidWorks, after I finish building it, I can push it into COMSOL and start simulating or modeling the system in COMSOL. You have also the CAD import module, where you can import CAD files from other softwares into COMSOL. But LiveLink also helps you with like lively changing parts and bits and pieces of your geometry. Or if you change some dimensions, you can just sync it up into your system without having to rebuild the system or rebuild the model from scratch. You can also have a script running in MATLAB, either extracting data from COMSOL or sending what's it called, an answer or a certain parameter into COMSOL. You have also can run can Excel macro, where you can connect Excel sheets into or Excel macros with COMSOL both ways. So you can have live link for all the mentioned CAD softwares like SolidWorks, Inventor, AutoCAD, Revit, PTC Creo, and Pro Engineer, Solid Edge, and CATIA V5. Let's take a look at the COMSOL interface itself. Let me just open the software. Okay, currently we have the software here. This is the interface when you start using COMSOL. The first screen you can see is new. So what you have here is Model Wizard and a blank model. If you use either, you're going to end up with the model you need. The thing is, I prefer using a Model Wizard because it takes you step by step to build your own model. Let's take a look of what we get if we click blank model. Okay, this is the interface you end up with the blank model. At the top, you have the tabs, and each tab includes many other buttons that help you with building your model. Whenever you select a tab, you get the ribbon with the buttons you would like to have. The same functionality of the tabs and the ribbon, you can find it in the model builder. Also, you can find the settings for whatever you select in the model builder apparent here in the settings window. And the last thing is the graphics window and the log text file text field, when you can find your graphics and build and geometry which you build. You can find your boundary selection. You can select your boundary from here, and also you can find your post-processed results appearing here in this geometry or the graphics window. Let's go back again to a new file. When I start opening the new file, I can select Model Wizard. The first question I get is what kind of space dimension I'm working with currently. If I select, for example, 3-dimension, the next step, I'm selecting here my physics, or what kind of features I would like to include in my system. If I go to File, License, and Use Products, I can find that most of the modules I have, except for the modules for CAD softwares, which I don't need, or MATLAB, which I don't have. But all the modules I have here are selected. So you can find all the features are included in my system here. So for example, let's select fluid flow, a single phase flow, and then select laminar flow. Now I'm adding this laminar flow to my physics. Whatever feature I found here for the physics, I can find a brief description about it on this right-hand side, and you can read more about it, or you can go to File, Help, and then click F1 or Help. And this will give you an interactive help with more information and a link to the documentation of the software, which you can find installed in your system when you install COMSOL Multiphysics. The detailed user manual is available in the installation folder as PDF. Next, I can select whatever kind of study I'm working with. Here, I can select whatever kind of study, either stationary or time dependent. These are the ones I have now. Difference between them, this is a steady state, more or less, study, and this is a time domain or time dynamic study. Let's select the stationary, click done. Now I've selected my physics and my study type, or my solver type. If you look at the structure in the model builder, you can find that there is something called global definitions and components under your model. My model called untitled.mph. This is my model. If I save it under whatever name I want, this will be changed. So if I go to my model, I can have a title for the presentation of this model and have a brief description, type the name of the author, and so on under the settings. I also can encrypt it, set a password, which you cannot open. You cannot open the file without the password, or you cannot edit the file without password. This is one option. Under the global definitions, these are definitions that are going to be applied to all the components in the system. So if I have a single component here, I can set up my parameters. For example, I can define, for example, a fluid flow velocity or a pressure point or whatever. All these values I can express in my parameters here, and they're going to be called upon in any component after this under the global definition. But if I set up any parameter or any function or any variable under the component itself, for example, in definitions here, I can go select variable functions or anything. This is going to be only available on the component. So the global definitions, you can have anything that can be called upon from different components. Whatever is inside the component cannot be seen by another component. The component is my space dimension. So I can add a component. I can add multiple components to the same model file. If I have a 3D model, 2D axisymmetric, two dimension, one dimension axisymmetric, and even an equation or a z-dimension model. So now let's take a look at the component. I have different nodes for definitions. If I look under definitions, I can see my variables, whatever kind of function I would like to call upon, probes, selections, and so on. So if I go to definitions tab, I can find the same exact tools here. If I'd like to know more about any tool, I can just press F1 or help, and this opens my interactive help, which tells me exactly what each and every node I'm clicking upon here means and what it does and what it's for. So if I go for example, boundary system, you can see whatever this means. If I select one of the physics here, for example, initial value under laminar flow, you can see also what does this node means and what it is used for. So next thing is the geometry. I can right click on my geometry and find all the geometrical tools I need to build the model, or I can go to the geometry tab on the top and I can find the same exact tools. So let's start by building a block, for example. Let's see how it works. If I click on a block node will be added here under geometry. Under the block node, if I select it, you can see that there are multiple input parameter fields here. So the width is 1 meter, depth 1 meter, height 1 meter by default. I can change the units here by going to geometry, changing my length unit, for example, to centimeter, which is going to change the default units to centimeter. Or if one of the dimensions is a different unit than the whole system, I can just type it as, for example, 1, open a square bracket, type meter, or square, close square bracket. Now I have 1 meter. And then building. So this is my cube. It's 1 meter in length, in width, and then all the dimensions are 1 centimeter. This is one way to typing units. You can type your units in any system, empirical or British, whatever, SI or any other unit system. And as long as you have the units between square brackets, it can be included and it can be translated or converted into COMSOL by itself. You don't have to convert every single unit. You can have part of it in SI, part of it in British units, and then it can be all converted internally. If you look at the position, this defines the position of this corner, which is at 0, 0, 0, 0. So this is the corner, or I can also define it as a center. So the center of this cube is going to be at 0, 0, 0. This way. So now the center is at 0, 0, and 0. This is how you can position multiple objects around your geometrical space by defining the position of the center or the base or the corner, what kind of object you have. You can have also different settings for this for each and every node. So if I go again to geometry, I would like to draw another block or a sphere. Let's do a sphere. My sphere, if I build it, is going to be 1 meter in radius, so it's going to be more or less covering the cube. If I want to see inside this sphere, I can have in this graphics window, I have settings to see as a transparency or wireframe. So if I have transparency switched on, I can see my cube inside my sphere. If I have wireframe on, I can see the cube stuck inside my sphere. If I would like to push the sphere out of my way, so for example, if I would like to push it 1 meter or 2 meters in the x direction, I can just go to position, 2 meters. That's 2 centimeters. My unit is centimeter. So 2 centimeters in this direction. Unclick my wireframe. Now my sphere is right next to my cube. This is one way of using the tools we have here. By clicking different types of, by adding different types of geometrical objects from this menu, you can then start welding them, for example, using the Boolean partitions, either union, intersecting, difference, composite. These are all tools you can find in COMSOL that you can help you build up your model or build up your geometry without needing to use any other CAD softwares. There are multiple tools also can help you, like workplane. You can convert your three-dimensional working area into two-dimensional piece of paper, you can say, drawing your geometry in 2 dimension and then extruding it, for example, or revolving or sweeping or lofting it to create a 3-dimensional object out of a 2-dimensional sketch. These are multiple tools you can find in COMSOL to help you use create your CAD system or uh, your CAD environment without needing to use other external softwares. Other than that, you can just import your CAD file or your geometry from other softwares using the import function, and then maybe repairing it if they have some features that are um, intersecting in a wrong way or something. You can repair it using some of the virtual operations or the featuring and repair tools we have in COMSOL. Next, let's go to select a material. If you can go to material tab up there, you can find add material. This opens the material library we have. So the more modules you have, the more sub menus you have in the materials, or the more pull down menus you have in the material library. For example, let's go for the built-in. We can add, for example, copper. If you look at copper, you can find the properties, material properties of copper here, which you can also edit if you would like. If you look here, you can find one of the materials has a green tick on it, and the other one has a red stop warning sign on it. When it has a red stop warning sign, that means that this material property is missing for this material to be working with the physics or the equation you have in use. So I have laminar flow, and I have laminar flow for this copper domain, which doesn't make sense anyway. So anyway, it requires dynamic viscosity. So that's why it will not be solved unless I provide the dynamic viscosity for this. Blank material. So if I go here, select a blank material. This is how I add a material that I don't have included into my system, or it's not available in COMSOL. For example, it's a proprietary material that I created in the lab, or I have it from a certain company that provided, which is not available in the material library. So now I have my blank material that doesn't have any material properties. I can go to material property, select one of these material properties, either, for example, basic properties. I can go for density, click add, and now my material has a density. I can fill in the density, for example, 1.2 kilogram per meter cube. This is very light. Now my material has a density. I can also rename it. If I go to material 2, I can call it test material, And then I can also save it by clicking add to use the define library. This is how I saved it to my computer. Now, if I open a new model or close this model without saving it, the material is saved already. So I can go to my material library again, add material from a library. I can use the user defined library. I can find my test material here. I can, as you can see, also I have two other materials which I used before and saved it to my library. Let's go to the physics part and we can look at the physics. Now I have laminar flow. We can go to physics and see this is my selection. It's laminar flow. I can add more physics or more equations or physics nodes if I want. I can add multiphysics, or I can grab a physics from another model. This is new one of the functions we can have. If you have a certain physics that's available in one model, you can grab just the physics from the model without using any other parts of the model, like the geometry or the parameters and so on. You can just grab the physics from it. You can also add domains. So these are the domains we can have to define certain domains in the geometry. Boundary conditions, if you have an inlet, open boundary, outlet, and so on. These are the boundary conditions, and so on goes the list. You can find the same exact input parameters or the input boundaries. If you right click on laminar flow, you can have this domain properties. As you can see, the domain selects the whole blue volume. Boundary selects just part of the blue volume, which is just the surface area of the blue volume. And then you have all those other subdomains from, for example, flow control devices and so on. Let's, for example, select an inlet. If you click an inlet, you can find a selection box where you can select your boundary from the geometry. For example, I selected this boundary, which is called number 8. Or I can add a boundary by typing the number here. For example, boundary number 2. So now I've selected also boundary number 2. I can also unselect it as long as this selection box is activated as green. You can see I can select and unselect from the graphics window. So I can unselect number 2. If I switch it off, now I cannot do anything. Nothing is going to be added to this selection box. Next, you can open the equation view. You can look at the equation of this node. You can also edit the parameters for this node. For example, I can have my normal inflow velocity as 1 meter per second. This is how you add your settings. So you set up your boundary conditions. I can have this as a single value, like 1 meter per second. I can have it as a function in other parameter. For example, I can tie it to a temperature. So it's a T power whatever times something, and this is my flow inlet velocity. It's a function in temperature. Or I can have it as a parameter. So I can type it as U1. So this is my inlet velocity, but it's going to be in orange because it's undefined. Next, I can go to my parameters, type U1. This is my name of my expression. The expression is going to be 2 meters per second between square brackets, as we said before. Next, I can say inlet velocity. Description is for later use. Next, when I'm referring to this model later, I can see the description of each and every parameter. Now the U1 is black and it's working because now it's defined as a parameter. You can add multiple boundary condition through this physics, either right clicking on it or going to physics menu on the top here in the tabs and selecting whatever boundary condition you would like to have. I can also add multiple physics. So I can add another physics, for example, heat transfer. So I can add a heat transfer physics, heat transfer in fluids, just an example. Under heat transfer, I can have also multiple nodes or multiple features under it. I can select the boundary conditions for this heat transfer or domain conditions from the menus. Now, if I solve my model as is, it's gonna be solved for laminar flow and heat transfer, each one separately without tying them together. So if I have it, if I want to have the multiphysics experience using COMSOL and having a multiphysics model between two of them, I would like to have a multiphysics coupling. So I can go to this menu or that button. I can go to add multiphysics, and you can have your multiphysics couplings. For example, laminar flow for non-isothermal flow. Double click on it. Now I have my non-isothermal flow coupling. If you select it, you can see it applies on both domains, these two, sphere and cube, and the fluid flow node is laminar flow SPF, which is this one, and the heat transfer node is this equation, heat transfer in fluid HT, which is this one. If you have multiple laminar flow and multiple heat transfer nodes, it's going to be HT, HT1, HT2, and so on, or SPF1, and then you can select whichever two physics you would like to couple from these menus. The next part is my mesh. This is when I start meshing my whole domain or domains. So I can go to mesh tab or right click on mesh here. You can find the same exact options under both of them. So I can select the meshing tools I have here. So I can select my boundary, which is what we're going to do next week. This is what we're going to do next week. So I can select whatever meshing tools I would like to have, apply it on, in the domains or boundaries, mesh it, mesh it, and then move along to the next one. Or I can use my automatic mesh. So here, if I look, my physics controlled mesh, this looks at whatever physics you have or multiphysics you have included in the system, the type of your domain or the shame of your domains, and then you can click just build all without any user interference, and it meshes the whole system automatically. You have also 9 predefined sizes for the mesh element, or you can see extremely fine to extremely coarse. These are different resolution. So this normal one, I have 39,212 domain elements. But if I increase the resolution or make it more fine, so for example, extra fine, build all, the number of domain elements or meshing elements is going to increase drastically this way. You can also mesh certain parts of your domain at a certain level of fineness or resolution. Mesh other parts at different type of meshing elements. So you have tetrahedral, quadrihedral, tetrahedral, and hexahedral elements. You have different types of elements you can use. As you can see, by increasing the number of elements and meshing resolution, it takes more time, and depending on your system, it can take much more time or less time than that. The more elements you have, the more processing power you're gonna need, the more RAM or random access memory on your computer you're gonna need. So optimizing your mesh is one of the crucial points if you would like to have a huge or run huge models or massive simulation models. Optimizing a mesh is a key to have an actual running model with limited resources. If you look down there, you have the amount of memory used. You have the physical memory, which is the RAM on the left-hand side, and the virtual memory, which is the memory mirrored on the hard drive and used as an actual, like a virtual RAM on the hard drive by Windows. This is the one on the right-hand side. It's taking forever, as you can see, but at the end, we're going to find a lot of elements of domain elements, and that's why it's taking lots of time. But based on what I said, as you can see, if you follow the workflow from the top to bottom on this model builder, you should not miss a step. So first thing, you define your parameters. Next, you define your geometry, or create your geometry, or import it, or whatever you want. And then define your materials. If you have multiple materials, and select the domains, set up the material properties that you want. Next, you define your physics or multiphysics by defining the inlets, outlets, and boundary conditions, and so on, depending on what you're working with. If you have multiphysics, also you can tie them or couple them together using multiphysics node. And then meshing, you can use the automatic or physics controlled mesh, or use the user defined manual meshing, domain, part, edge. And then when it's done, you can see that the next node is study. If you have the certain study settings you'd like to apply, you can apply there. If, for example, if you're using time domain or a time dependent study, you can select your time domain. If you're using a frequency domain study, you can select your frequency range or just single frequency. And then last thing you can find is the results node, where you have your results plotted when you finish your model. By default, each physics in COMSOL has its own default plots, or each also multiphysics has its own default plots that are automatically generated. But you can create whatever result or plot, meaning post-processing, you would like to have. You can export your data as Excel or like a tabulated result as Excel sheets, as if you want. You can have two-dimensional, one-dimensional, three-dimensional plots. You can have also reports as documents, a Word report, which you can take a look next week or post-processing our model. You can also export your results as a GIF or an AVI movie if you have multiple frames in your result. There's lots of way you can slice into your geometry and see what's inside in the result. Post-processing using COMSOL shouldn't require you using any other software to extract data or plot data or present data out of your model. I think this is a huge mistake to go for this extra fine resolution in the element size. Anyway, it should end very soon. But as a sneak peek for next week, we're gonna talk more about COMSOL interface. We're gonna start using actual model. We're gonna discuss a first example before we start, and then we're gonna step by step create it in COMSOL. If you have COMSOL, you can look at file. Sorry, if you don't have COMSOL, you can go to file menu on the top here, and you can find lots of example being solved under application library. You can find lots of examples, solved examples, and instruction files with PDF instructions in each and every file. Okay, as you can see here in this log sheet, our first trial using a normal mesh size was 39,212 domains. Now we have 1,495,130 domain elements. So increasing the resolution of the element, or the reducing the size of the element, increases the number of elements per geometry or per domain. As you can see, it's almost black from outside, and when you zoom in, you can find very fine elements in the model. Let's take a look at what kind of result plots you can find. If you go to two-dimensional plot groups, you can find lots of other tools here. A plot group is so you can say it's an empty portfolio or an empty folder with whatever plot you can put inside. So if you can have a volume plot, a slice, an isosurface, or just a surface, whatever plot or multiple plots you can put inside, and all of them will be expressed overlaying each other. So you can first select your results and then select whatever kind of plot group, and you can change the name of this plot group. And after you select your plot group, you get the types of plot that are applicable for this plot group, and you can put them one by one. For example, if I want to go to click a surface here, so I have a surface, two-dimensional surface expressed. Under the expression, I can select whatever expression I would like to include in this plot. So these are the form or the syntax we write in. If you don't know what exactly the name of the expression that is in COMSOL, you can use the replace expression tool. So if I would like to, for example, express the pressure, so I can type pressure. So velocity, laminar flow, pressure, which component one, which is this component one, dot P. So this is the pressure from component one. Now I have my pressure plot. The unit, I can change the units from this menu, and then I can change the coloring and style, the range of the plot. I can put a legend, remove a legend, and so on. We can all see this stuff being applied next week